Okay, this is chapter 8.2, proving triangle similarity by AA, angle. Essential question. What can you conclude about two triangles when you know that two pairs of corresponding angles are congruent? What will you learn? Use the angle similarity theorem, and you will learn how to solve real-life problems. All right, so let's take a look. Okay, so let's start off this chapter section with a theorem. It's the third theorem of the chapter. First one of this chapter section. Theorem 8.3, the angle AA similarity theorem. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. If angle A, one arc, is congruent to angle D, one arc, and angle B, two arcs, is congruent to angle E, two arcs, then triangle ABC is similar to triangle DEF. There's a proof on page 428, but we're just going to go with a theorem for now. All right, so let's take a look. Okay, so here's example one, using the angle similarity theorem. All right, so it says determine whether the triangles are similar. If they are, write a similarity statement and explain your reasoning. Okay, so take a deep breath. 90 degree. So right now I can say the measure of angle D equals the measure of angle G because they both equal 90 degrees. So that's an angle. But then I have a 26 here at C. So the measure of angle C equals 26 degrees. And over on the other triangle, the measure of angle H equals 64 degrees. Well, those don't correspond. D and G do, and they're 90 degrees. So I need to do the triangle sum theorem. So off to the side here, I'm going to say the measure of angle C plus the measure of angle D. Whoops, D, angle 9, angle D. I also could do the theorem about the two angles, acute angles in a right triangle are complementary, but I'm going to do the triangle sum theorem here, plus the measure of angle E. So C plus D plus E, triangle sum theorem, they add up to 180 degrees. Substitute my givens. C is 26 degrees, plus D is 90 degrees, plus the measure of angle E we don't know. So there's our substitution of our givens. Combine your like terms, 6 plus 0, 2 plus 9, plus the measure of angle E equals 180 degrees. Get E by itself by subtracting 116 degrees from each side. Oops. So like that, that cancels, and you get the measure of angle E equals 10 minus 6 is 4, 7 minus 1 is 6. So the measure of angle E equals 64 degrees. So now I know E is congruent to H. So I can say that the measure of angle D equals the measure of angle E equals 64 degrees. And that's another angle. So I can now say triangle CDE is similar to triangle KGH. I'm trying to do it in the same order. D and G have to be in the middle because they're 90. C is 26, K is 26, so those have to be first. So to do this properly, you have to order the corresponding parts in the right order. So triangle CDE is similar to triangle KGH by the angle similarity theorem. Okay, and there's my statement. Explain your reasoning. All right, so now that I've done that, you should be able to do problem number 3 through 6, 3, 4, 5, and 6 in your exercises. Okay, example 2 says using the angle-angle similarity theorem, show that the two triangles are similar. Okay, so in triangle, in A, triangle A, B, E is similar to triangle A, C, D. That's what we want to show. They're not saying they are. It says to show that these two are similar. How are we going to show that? Well, I broke these apart. So here's the little triangle, and that is going to be A, E, B. So that's triangle ABE. So this is triangle ABE. That's this one. That's the little one. And I know this is 52 degrees from here. That's angle ABE, or in this diagram, you can just say angle B. The other triangle is this bigger one right here. I'll put it right here. And this is also A. This is C, which is 52 degrees. And this is D. So we have two triangles. Now remember where these came from. Angle A, by the reflexive property, angle A is congruent to itself, because if we pull these two triangles apart, these two triangles were on top of each other like so. So angle A equals itself over here. Okay, so I have the measure of angle A equals the measure of angle A, and that's reflexive. And obviously, angle B is congruent to angle C, because B is 52 and C is 52. So this is an angle and this is an angle. So now I can say triangle ABE is similar to triangle ACD by angle similarity theorem. Okay, so that is part A. Now part B, I did something similar. Part B, I copied this SRV, Stevie Ray Vaughan triangle. Now, if I were to rotate this around, you will see that it is a rotation of VTU, and it's same shape, different size. So I just want you to be aware of that. So now that that is rotated, this is S. R is up here, and V is right there. Okay? So what we're trying to prove is triangle SVR is similar to triangle UVT. Okay, well, we have two sides that are parallel. The other thing we know is that vertical angles are congruent. So you could say angle SVR is congruent to angle UVT. And it's because they're vertical angles. Vertical angles are congruent. So that's one pair of angles. Now I have parallel sides here. And RS is parallel to TU right here and there. So since RS is parallel to TU, think of SV as a transversal. So I could say angle S is congruent to angle U. Let me put two markers there because they're not congruent to these. Angle S is congruent to angle U because they're alternate interior angles. These two lines are parallel and the SU is a transversal. So then I could say angle S is congruent to angle U by alternate interior angles theorem. And so now I know that triangle SVR is, oops, not equal, not congruent, but similar, one squiggle, triangle UVT. And the reason is by the angle similarity theorem. All right, so now that I've done these two examples, you should be able to do problem numbers 7, 8, 9, and 10 in your exercises. Okay, example 3, modeling with mathematics, a real life situation. The flagpole casts a shadow that is 50 feet long. So here's a flagpole in front of a building. So this distance right here from that to that, the shadow is 50 feet. At the same time, a woman standing nearby who is 5 feet 4 inches tall. So her height is 5 feet 4 inches, casts a shadow that is 40 inches long. Okay. All right. So we've got inches, we've got feet. That's not a good thing. How tall is the flagpole to the nearest foot? So we want to convert her to feet. Or base it on feet to inches, if you will. So let's take a look at how we're going to do this. First thing we do is step 1. We're going to understand the problem. You're given the length of the flagpole shadow, the height of the woman, and the length of the woman's shadow. You need to find the height of the flagpole. So that's the key to this problem. We want to know, what are we trying to find? We're trying to find the height of this right here. So notice what we're doing here. We have a big triangle with a 90-degree angle, where the base is the shadow, the height is the pole, and the hypotenuse is the distance from the top of the pole to the end of the shadow. Same with here. We have a woman who's standing here, and we have a triangle. The base is her shadow's length. Her height is the height, and the distance from her head to the tip of the shadow is the hypotenuse. So it's 2 right triangles. So we have one angle congruent to one angle, and the angle of the sun would be the same at the top. So we have an angle similarity, 2 triangles that are similar. So we can set up a proportion because the lengths are proportional. So that's the whole key to this problem. So step 2 says, using similar triangles to write a proportion and solve the height of the flagpole. Okay, yes, that's what we do. And so step 3, solve the problem. So the flagpole and the woman form sides of 2 right triangles with the ground. The sun's ray hits the flagpole and the woman at the same angle. So that top, as I said, the top angle, okay, the vertex angle is equal. And they extended it to show that that's the sun's rays coming down from the sky. And you have 2 pairs of congruent angles because of the right angles. So that's the 2 triangles are similar by angle. So the height of her is 5 feet 4 inches. Her 40-inch shadow goes to x feet height of the pole, which we're trying to find, and the base is 50 feet. Okay, so the next thing we're going to do is, whoops, I didn't want to do that. We're going to first write a proportion of side lengths. So we have x feet over 64 inches equals 50 feet over 40 inches. So there's our proportional setup. And what did we just do? X feet, so the height of the pole over 5 feet 4 inches. Well, 5 feet is 60 inches, so 64 inches is 5 feet 4 inches. 60, that's what this is. 60 inches is 5 feet 4 inches. Equals 50 feet, the shadow, compared to the shadow of her. So the height of the pole, so I'm going to put height of the pole over the height of the woman equals the shadows, the pole's shadow over the woman's shadow. They have to be in the right order or you'll get the wrong answer. Okay, so then we have cross multiplying. We get 40 times x equals 64 times 50, which is 3,200. And then that simplifies to 80. Okay. But I'm going to do this a little bit differently. I don't like mixing feet and inches. So I'm going to do this. I'm going to put it all in inches. What are we trying to find? How tall is a flagpole to the nearest foot? So I'm going to put it on feet. Well, 5 feet. Well, what's 4 inches? 4/12 of an inch is 1/3 of a foot. Okay, so that's 5 1/3. She's 5 1/3 feet tall, which is 16 over 3. So I'm going to replace that 64 with 15 over 3. So it would be x feet divided by 16 over 3 feet equals 50 feet over, and then this is 40 inches, the length of her shadow. Well, 12 inches in a foot, 3 feet is 36 inches with 4 inches remaining, or 4/12, which is 3 1/3, which is 10/3 feet. Okay, 3 feet and 4 inches. Now when I cross multiply, I get 10 over 3x feet equals 50 times 16, which is 0. 6 times 5 is 30, carry the 3. 5 plus 3 is 800 over 3 feet. Okay, and to get rid of this 10/3, I'm going to multiply both sides by 3/10. Okay, so the 10s cancel, the 3s cancel, and I get x equals, the 3s cancel, and I get 800 divided by 10 is 80 feet. Okay, we got the same answer, but I just don't like mixing inches and feet. Get in the habit, if you're going to take a science class or physics especially, to get all your units of measurements first, but we did get 80 feet both ways. Okay, so that's that example. Let's see what else is in here. All right, you know what else is in here? Nothing. That was a really short lesson. 3 examples. Booyah, done. 8.2 exercises. Do these problems. Thanks for watching. Have a great day.